STEM fields are rapidly innovating as researchers use new computational tools to aggregate, analyze, and represent data about the natural world. So how can schools integrate computer science into STEM classrooms so that students can engage in authentic computational experiences? The Building Systems from Scratch project seeks to provide authentic computational experiences by interweaving game design and climate science learning in 8th grade classrooms. In our project, students use Scratch, in which programming commands are represented as colored blocks that snap together like Legos. It's an intuitive yet rigorous way to learn, and is a good building block towards text-based programming later. While student gains in computational thinking from using Scratch have been well documented, few researchers have studied its integration in STEM. Additionally, while the development of educational games has exploded, we conjecture that learning from designing games will actually be a deeper and more meaningful experience for students. Our project is based on the idea of constructionism, the idea that when young people create objects, they create knowledge at the same time. We view students as knowledge producers, and classrooms as networks of student expertise. In practice, this means that students in our project program in collective pairs. They do independent research on climate science content, and they engage in critique sessions that are design studio inspired. After participating, students showed significant gains in content knowledge, and they perceived an increase in their efficacy at integrating computational thinking in science.
Overall, watching the kids kind of build their understanding and really look at what they needed to know to build the game was kind of a really interesting thing for me. So that was kind of really nice to see that when they were working kind of independently or with partners.
Students also integrated a systems approach to thinking about climate change.
I think because we talked about systems and then they did Connection Circle and then they were thinking about systems even if their game didn't show it, I think that really helped them internalize system more than I saw last year, although this is only my second year teaching systems.
No, I definitely saw it too, that they really have a good idea of how systems and how things interact, and that's just ingrained in them now.
Going forward, we will be integrating the program into all 8th grade classrooms in a Boston area school district, and eventually expanding to 2 or 3 other districts. While much has been researched about what students can learn from playing games, there's been less research about what students can learn from designing games. We have shown that students can learn about systems and climate change through game design.